Hello everyone, welcome back. This is Mr. Osam Wasapi. So in this video, we're going to continue on limits of trigonometric functions. Alright, so before we begin, do not forget to like and subscribe to the channel. So this is part 2. Now, before we look into some examples, I just want you to remember something. I did look at limit identities. The first identity was that if you have the limit as x approaches 0 of, say, sine x over x, this is equivalent to 1. The second one said if the limit as x approaches 0 of x over sine x will also be equivalent to 1. The third said that the limit of x approaching 0 of 1 minus cos x over x is equivalent to 0. And finally, the limit as x approaches 0 of x over 1 minus cos x is also equal to 0. Now, with this said, we can now quickly look at some examples that are attached to these identities, but be mindful that under trigonometric functional limits, the whole goal is to manipulate what you have. Alright. So, suppose we have examples and we have been told to evaluate the following. So what we'll do is quite simple. We'll apply the trig limit identities to solve these questions. So suppose you have a question such as lim as theta approaches 0 of sine of the root of 2 theta over root of 2 theta. Now, remember, we had an identity that had sine something over x, of which sine something over something is like 1 having sine x over x. So in this case, we're having the root of 2 theta. So what we can do here to solve this question is just to let root 2 theta be equal to say x, and this will be the lim as theta, of which theta will now be x approaches 0 of sine x over what? X. And remember, this gives us what? 1. So this means that the limit of theta approaching 0 of sine of root of 2 theta over root of 2 theta is equivalent to 1. Alright, all is clear. So you can pause the video and attempt to do this one. So limit as t approaches 0 of sine of k t over t. Now be mindful that here k is a constant, so where k is the constant. So now how are you going to do this? So the first thing we can do is simply just let t equal to x. That said, you have lim as x approaches 0 of sine of kx over x. Now, you can manipulate this by saying that algebraically I can introduce k over k. And what am I going to have in turn? I have the limit as x approaches 0 of, if I manipulate this, I'll have sine of kx over kx times k over 1. Now, this portion here satisfies the condition that if you have the lim of x approaching 0 of sine x over x will give you 1. So now this means that what you have here is equivalent to 1 times k over 1. In the end, this will just give you the final answer to be k. Let's look at question number 3. So you have the limit as t approaches 0 of 2t over tan t. So you can pause the video and attempt to do it on your own. So let x be equal to what? T. Then you'll have lim of x approaches so x equal to t, yeah. So it's going to be x approaches 0 as 2x over tan x. So you'll be having something like let me say lim as x approaches 0 of 2x over 1. If I push out a tan, I have 1 over tan this side. So 1 over tan x. Now remember, 1 over tan x is simply equivalent to cos x over sine what? X. So here it's like you're having now a statement where you're having the limit as x approaches 0 of 2x over 1 times cos x over sine of x. Now, upon having this, you can find means of manipulating this. So I can manipulate in this manner. I can say lim as x approaches 0. I can create identities out of these from the identities that we learned. So I could have this such as 2 cos x over 1 times x over what? Sine x. Now, what I can do from this point is to introduce the limit properties. So I can take each limit independently. So what I'll do is this. I'll take the lim as x approaches 0 of 2 cos x over 1 separately. Then also take the limit as x approaches 0 of x over sine x. So we know in this portion, all we have to do is to plug in. So if we plug, we have 2 cos 0. And this side, we know the identity that we have here will give us 1. So we know cos 0 is 1. So we're having like 2 times 1. And final answer will be equivalent to 2. Alright, so this should be question number 4 if I'm not mistaken. So suppose you have the limit as x approaches 0 of x cosecant, let's make it interesting, of 2x over cos of 5x. So now through manipulation, you can have this lim as x approaches 0 of x over cos of 5x times cosecant of 2x. Now we do understand that this is the same as 1 over sine. So you have the limit as x approaches 0 of x over cos 5x times 1 over sine of 2x. So this would be put in a manipulative way where we can introduce 2 over 2. Yeah, I think that would be better. So in this manner, if we do introduce it in such a way, introduce 2x over 2x, we will end up having something of this sort. So lim as x approaches 0 of, say now you have something as 2x squared over cos 5x times, okay, so let's not manipulating this, well, let's say x over cos 5x times, let's get this, put 2x there, over sine 2x, then times 1 over 2x. Oh, that would be better. Now, what we're going to be having now is a scenario where we know that, okay, this will give us 1. But I can get this x here and fold it out with that 1. So I can have lim as x approaches 0 of 1 over cos 5x times 2x over sine of 2x times x over 2x, of which this x can cancel out with that x. So you have the limit as x approaches 0 of 1 over cos 5x times 2x over sine of 2x times 1 over 2. So we know here if we plug in, we take the limit independently, 1 over cos 0 will give us 1. This 2x over sine 2x also give us 1 times half. So this implies that the final answer is just going to be half. Yeah. So this is how you go about solving questions involving trig functions on limits. The key is just to manipulate. If you can manipulate your work, then you are safe. So we'll just look at the last example, which will be the lim of x as x approaching 0 of 6x squared of cot x of cosecant of 2x, like that. So all we're going to do is just manipulate this in a manner that we can understand. So we have the limit as x approaches 0, so this can be manipulated as 6x squared times 1 over tan x times 1 over, this would be sine 2x. So this implies that you can have something of this sort. So you have the limit as x approaches 0 of 6x squared times cos x over sine x times 1 over sine of what? 2x. So through manipulation, you end up having a limit as x approaches 0 of, if you start falling out and manipulating this, you end up having a scenario where you have 6x squared times, let's just put it in a way that can be simple to understand. You will have cos x times x over sine x, because I pull out the x from 6x squared, then times, then if I pull out the 2x from what I'll have 2x like that over sine of what? 2x, and I remain with 3. Because if I put this back all together on the numerative part, to get a 6x squared. And if I take the limits independently of what I have, I'll be having here, the first one will be 1, second one will also be 1, third will also be 1, and the last will be 3. Therefore, my final limit will just be what? 3. Alright, thanks for watching. My name is Mr. Hussein Mwasabi. Don't forget to like and subscribe to the channel. If you have any questions, you can reach me on WhatsApp on the number attached to the screen or the number I've put in my description. Remember to strategize before you become a statistic, and let's try and push for that A+.